In section 7, finding rational roots, we're going to put everything together that we've learned so far, and in this case we need to find all the roots. To help us with that, we'll need something called the rational root theorem. And it says if you have a polynomial function p of x that's a to the sub n times x to the n power plus a to the sub n minus 1 times x to the n minus 1 power plus etc. down to a sub 1 x to the first plus a sub 0. In other words, we have a polynomial in descending powers of x, and then we have the coefficients that go along with them. All the coefficients here are integers. What we want to do is start finding a rational number c over d, where c and d are relatively prime to each other. And if c over d is a root of the polynomial, c must be a factor of the constant, a sub 0. D must be a factor of the leading coefficient, a sub n. Now that'll make more sense when we actually put this to use in example 1. So let's take a look. What they're saying here is our leading coefficient is 3. Our constant is negative 4. So I'm color coding them. C represents the constant. D represents the leading coefficient. So I'm going to take all the possible ways of factoring negative 4. Could be positive 1 times negative 4. Could be negative 1 times positive 4. It could be positive 2 times negative 2, or it could be negative 2 times positive 2. So my list of all the factors of negative 4, c, the constant, is plus or minus 1, plus or minus 2, plus or minus 4. Going to do the same thing with the leading coefficient 3. Could be positive 1 times positive 3, or negative 1 times negative 3. So plus or minus 1 and plus or minus 3 are the ways of factoring my leading coefficient 3. So we've got list for C, list for D. I need to take all the possible combinations of C over D. So I can have plus or minus 1 over plus or minus 1, which is plus or minus 1. Plus or minus 2 over plus or minus 1 is plus or minus 2. Plus or minus 4 divided by plus or minus 1 is plus or minus 4. And then all the numbers over plus or minus 3. So plus or minus 1 over plus or minus 3 is plus or minus 1/3. Plus or minus 2 over plus or minus 3 is plus or minus 2/3. And plus or minus 4 over plus or minus 3 is plus or minus 4/3. Now read the problems carefully, especially when we get to the test, because this problem just says list the possible rational roots of the polynomial. There are 2, 4, 6, 8, 10, 12 possibilities. We know they're not all going to work because in the previous lesson we learned the fundamental theorem of algebra. We have x to the 4th. There are only 4 actual roots of this polynomial. I have 12 possibilities. So I've underlined to emphasize that these are possible rational roots. Now we're in regular algebra 2, not honors algebra 2, so let me give you the good and the bad news. It's possible that none of these could work. However, we don't encounter that in regular algebra 2. They're just possibilities, not actualities. Now notice the wording in example 1 compared and contrasted to the wording in example 2. Example 1 was to list all the possible rational roots. Example 2 is to find all the roots. Not possible, so we're looking for the actual roots. And for simplicity's sake, let's use the exact same polynomial we did in example 1. So we already know what our possibilities are. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 1/3, plus or minus 2/3, plus or minus 4/3. 12 possibilities. How do you know which ones are actualities? Well, glad you asked. We do synthetic division. That's why we learn synthetic division, because it's nice and quick and easy. And so we just start in our lists with all 12, and we just start doing synthetic division to find out where we get a remainder of 0. Remember from the previous lesson, if we get a remainder of 0, then that means this number over here is a root. So let's just go quickly and just take my word for it. I started with positive 1, did synthetic division, I did not get 0 as a remainder. So positive 1 is not a root. So I'm going to ignore that, go on to negative 1, and see what we turn up with negative 1. So synthetic division, bring down the leading coefficient, multiply by negative 1, put that in the next column and add to get negative 14, times negative 1 is positive 14, Put that in the next column and add. 0 plus 14 is 14. Times negative 1 is negative 14. Added to a positive 10 is negative 4. Times a negative 1 is 4. Added to a negative 4 is a 0. Now some of you are going, you must be kidding. No, we're not. You need to do synthetic division until you find a remainder of 0. Now, once we found a remainder of 0, we're going to turn things around a little bit. First of all, we've got a remainder of 0, so we know that negative 1 is a root. And from the previous lesson then, we also know from the fundamental theorem of algebra that x plus 1 is a first factor. We know that we need to find 4 roots and 4 linear factors. 1 down, 3 to go. Question is, do we proceed through the rest of the lists? And I would say no. Let's look at this quotient. There's my constant, x to the first, x squared, x cubed. That's my depressed equation, because we started out as x to the fourth, and we now have x to the third. I'm going to make an entirely new list of all the factors of my constant, negative 4, over all the factors of my leading coefficient, positive 3. Now, this happens when 1 or negative 1 turns out to be a root. This list is the same. If it were some other thing like 2 or negative 2 or a half or negative a half was a root, we would have a different leading coefficient, different constant. We would have a completely different list of possible rational roots. So we're going to work with a smaller list, and yes, we're going to start synthetic division again, only on the depressed equation. 3x to the third, negative 14x squared, 14x to the first, negative 4. And I know that this is time consuming, but imagine having to do this all with long division rather than synthetic division. Now I'm going to save a little bit of time here, and just trust me, positive 1 did not work, negative 1 did not work, positive 2 didn't work, negative 2 didn't work, positive 4, negative 4, neither one worked, 1/3, negative 1/3 didn't work. We know that because I secretly tried them. Just not going to consume our time and our screen here by showing you all that. And now I'm ready to try positive 2/3. So I bring down the leading coefficient. 3 times 2/3 is 2. Added to negative 14 is negative 12. 2/3 of negative 12 is negative 8. Plus 14 is 6. 2/3 of 6 is 4. Plus negative 4 is 0. So yes, what you didn't see is 2, 4, 6, 8 synthetic divisions that didn't work. But now this 9th synthetic division of positive 2/3 does work. So we had a remainder of 0, which means 2/3 is my second root. And here's the other good news. Let's look at the quotient. It's a doubly depressed equation. We started out as x to the fourth. We're now down to x squared. So going from right to left, my constant, x to the first, x squared. When we finally get our depressed equation to a quadratic equation, stop doing synthetic division. It is possible, and yes, very likely, that none of the other choices are going to work. Negative 2/3 probably won't work. 4/3, negative 4/3 probably won't work. When we get it to the quadratic, let's just put it in the quadratic formula and get my remaining answers. We don't have to guess and do synthetic division to find out. So a is 3, b is negative 12, c is 6. Substitute that in the quadratic formula. Start simplifying. So we've got 144 minus 72 under the discriminant, and then denominator of 6. 144 minus 72 for the discriminant is 72, which can be thought of as the square root of 36, which is 6, times the square root of 2. There's a greatest common factor in the numerator of 6. When I divide that out or factor it out, 12 divided by 6 is 2. 6 square roots of 2 divided by 6 is the square root of 2. So the remaining two answers we would not have found using the rational root theorem because they are irrational roots. 2 plus the square root of 2, 2 minus the square root of 2. And in the previous lesson's theorem, the conjugate root theorem for irrational numbers, if you have an irrational root, you also have its conjugate. So to recap, we were looking for 4 roots. We found negative 1 by synthetic division and using the possible rational root theorem. And then we found 2/3 by synthetic division. After that, we got our depressed equation, which was a quadratic. Put it in the quadratic formula. and got our remaining two answers, so we have all four roots of my polynomial, which is x to the fourth. And again, we won't do this to you in regular, but in honors, you can try all the possible rational roots and they don't work, so we will have to look at some other tricks for that. But we don't do that in regular algebra 2. So that's our look at finding the roots of a cubic polynomial or a polynomial raised to the fourth power.